The standard is 8.EE.8b, solve systems of two linear equations in two variables algebraically. And our essential statement is I can solve a system of equations by substitution. So the first method to solving a system was by graphing, which you had to graph both of your equations in order to get your answer, which was an ordered pair, x comma y. So today we are not going to be graphing at all. We are going to be using algebra to solve our system. We are still going to get an answer that is x comma y, where x equals and y equals a number, but this time your system will be solved algebraically. So what is the substitution method? The substitution method is used to solve a system of equations by solving an equation for one variable and then substituting the resulting expression into the other equation. So for this lesson, I will already give you problems that have one of the equations solved for one variable. So you'll get something that has y equals or x equals, just to make it a little bit easier to learn this method. So we're going to go ahead and get started with our examples. So here's our first example, and we want to solve this system by substitution. So what we've done before is we would have graphed these, or for example, the second equation right here, which is in standard form, we would have changed so it equaled y equals mx plus b, and then we would have graphed it. However, today you're given one equation in slope-intercept and one equation in standard form, and you're going to use substitution, no graphing involved. So how am I going to solve this? Well, luckily, one of these equations, the top one in this example, is already solved for one variable. It already has y equals something. So I'm going to go through this problem slowly, and then the second one hopefully will make more sense. So what do? Well, in this case, what I want to do is I want to take my, let's say, harder, or the equation that looks more difficult, the one in standard form. I'm going to take this equation and I'm going to rewrite it. Now, when I rewrite it, I see that my first equation that has y equals something, it's already solved for y. So when I rewrite the equation that's in standard form, I'm going to replace the y with parentheses, because that's what I will be substituting in. So if you think about it in terms of real life, let's say I am absent one day, but we still need a teacher, so they call in a substitute to replace the teacher that is absent. This is kind of the same thing. We have two equations and we are substituting one of the equations into the other one to help out. So here we know that y equals negative 2x. So what I'm going to do is I'm going to circle what y equals. This helps for visual purposes. So I know that y equals negative 2x. I'm going to plug in what y equals into the y of the second equation right there. So negative 2x. Now that is probably the most confusing part so far. And then what we do is we have to use everything we've learned in math class so far in regards to solving equations, using the distributive property, combining like terms, two-step equations, multi-step equations in order to solve this problem. What I like to do always is to draw a line down the equal sign. Next, I look at the left-hand side. I'm going to think about the order of operations in PEMDAS, which means I need to get rid of the parentheses first. In this case, in order to get rid of the parentheses, I have to distribute whatever's in front of the parentheses to everything inside of the parentheses. We only have one term in there, so we only multiply out once. So positive 2 times negative 2x is negative 4x. And then we bring down everything we didn't use, which was the 5x and the 1. Now when we get to this point, we see that we have two x's on the left-hand side, which means we are going to be combining like terms. So we have a 5x and we have a negative 4x. Those are the only two things on that side, so we can combine those. So when I combine 5x minus 4x, I get 1x. So this is x, and that equals 1. Well, that was pretty interesting how that worked out. So I know that x equals 1. And you're like, woohoo, I'm done. Well, no. Remember, our answer is an ordered pair, x comma y. So we're only halfway done, but we've done most of the work already, okay? But we only have half of our answer. So how do we get the second part of our answer? Well, we take the equation in which we circled. So we circled this equation right here, and we're going to write it down. So let me go ahead and write it down. Y equals negative 2x. And we just found that x equals 1. So we're going to take that and we're going to substitute it into the first equation. And so then we have negative 2, open our parentheses, and we're going to plop the 1 in there. So y is equal to negative 2 times 1, and therefore y equals negative 2, because negative 2 times 1 is negative 2. And there's our second part of our answer. But we aren't done yet, because why? Well, because we need to write our answer in ordered pair form. So our answer is actually 1 comma negative 2. Okay, so hopefully, I know I have a lot of arrows written down and drawn on this example, but hopefully the arrows, if you're following along and not skipping through the video, hopefully the arrows make sense. All right, let's do one more example. Okay. So this is negative 3x minus 5y is equal to 21, and y is equal to negative 4x plus 6. So this may be a different example than the one you saw in the lesson, but that's okay, because you want to do more example problems. So what am I going to do in this situation? Well, I'm going to do everything that I did in my first example. I'm going to take the equation that's in standard form, the harder one of the two, and I'm going to rewrite it. Now, looking at my second equation, I see that this is already solved for y. So it's y equals. I'm going to go ahead and circle what y equals. Again, this helps visually. And because it's y equals, I'm going to rewrite the first equation so that where my y is, I'm going to put parentheses. So all I did was I rewrote this equation up here, but I put parentheses where the y was. Now, once I do that, I know that y is equal to negative 4x plus 6, so I'm going to substitute that in right over here, negative 4x plus 6. And then I'm going to go ahead and solve for my unknown variable, which happens to be x in this situation. I'm going to draw my line down the equal sign. Then I'm going to distribute. And the way I distribute is by taking the number on the outside of my parentheses and multiplying it by everything on the inside. So we have two terms that I have to distribute to. So negative 5 times negative 4x is positive 20x. And negative 5 times positive 6 is negative 30. So this is very important that you use the sign in front of the number to solve and distribute, because if you forget the sign, you will not get the correct answer and it'll mess up the entire problem for you. And then I'm going to bring down everything I did not use. And once I get to this point, I will be combining like terms. So this goes back to when we did the shapes, the circling, the boxing, and the triangles of the same things. So I have a negative 3x right here, and I have a positive 20x right here, and then I just have a number at the end. When I combine negative 3x plus 20x, I get positive 17x, and then I bring down everything I didn't use. And now this just becomes a two-step equation problem where you draw a line down the equal sign, you find the side with the variable, you find the number not attached to the variable, and perform the opposite operation. But whatever you do to one side, you must do the same thing to the other. So negative 30 plus 30 goes away. It looks like I ran out of room, but that's okay. And then I bring down everything I didn't use, which happens to be 17x, and 21 plus 30 equals 51. And I'm gonna go ahead and do the rest of this over here on this side. 17x equals 51, okay? And then my last step in this case is to divide by the number in front of x, so I divide by 17, but whatever I do to one side, I must do the same thing to the other. And I get x is equal to 51 divided by 17, which is 3. Okay, so x equals 3. Now, again, we're only halfway done because we only have half of our answer. So once you get to this point, you then take the equation that you substituted in and rewrite it again. Okay, so the equation that I substituted in was y equals negative 4